Our final project video presentation part 1, the solar power plant security system. We are the team Linabell, and I have two teammates. They are Yixin Wu and Donghao Zhao. So our product is a cloud-based IoT system which can be installed on the solar panels in power plant facilities to realize multiple security functionalities for the solar panels and also the batteries. So what functions can our product realize? The first thing is that it can collect every solar panel's real-time GPS coordinates, the acceleration data, angular velocity, and other inertial measurement data. And it can alert our users over SMS or emails when the solar panels are moved. And it can also sound alarms on speakers when the solar panels are moved. And it can also display every solar panel's real-time global positions on the web-based map application. And it can also allow our users to set every solar panel's initial GPS coordinates. And it can allow our users to turn on or turn off the alerts for the solar panels movements on the web page.
Now I'm going to give you a brief introduction to our system design. At first, the X dot will collect data from the sensor like IMU, GPS, and send the data to the gateway multi-tech conduit. Then, by using the Amazon IoT MQTT service, the data will be passed to a stream and to the AWS Lambda function. The Lambda function will analyze the data and decide if the solar panel is moved or not. Then Lambda will write data to the database in the AWS. And the EC2 instance will query database from time to time. And in EC2, we will deploy a website server. And according to the data from the database, to run a real-time map to show the real-time location of each solar panel. Therefore, the user can check the location of the solar panels. And based on the order from the user, EC2 server will send the command back to the gateway through MQTT to control the speaker. Now I'm going to connect the conduit gateway to the router in my house and make the conduit gateway get connected to the internet. And first, I found the router IP address of my private networks, and so I pick this one as the IP address of a conduit. And the first command is used to configure the internet interface IP address, and the second I needed to configure the default gateway, and the third we needed to configure the DNS server of the conduit to make sure it connects to the internet.
Hi, so what you can see on the screen is the code for the XDOT, and this is the IDE for the XDOT. So in the main function of the program in XDOT, our mission is to send all the data from the XDOT to the gateway, and since our sensors has not been configured yet, so we have made some demo like the sample data. And the first thing is that we convert them into a vector of char because the XDOT can only send the vector of char to the gateway. And we use the comma to separate every domain of the data, and we save them one by one in the whole vector of char. And in the end, we invoke the API send data from the XDOT to send all the data to the gateway. And we can compile it here. So after the whole codes are compiled, we can show it in the folder. We can see it here, and we put it into our xdot. We press the reset button on the xdot, and we paste it here. So after the file is transferred to the xdot, we press the reset button again, and the xdot is running now. And then let's open up our Node-RED on the gateway. This is the whole flow for the gateway to receive the data from our xdot. So the first block is a LoRa block, and it can receive the data sent from our xdot. And once we receive the message from our xdot, it will process the message and get all the sensor's data, like to split them by the comma, and we get the data we want. And then the last thing is that we send all the JSON files to the MQTT, and we also put a debug block here to check if our messages are correct. And we can see that all the debug messages are shown here. You can see that the JSON files has all the key and value pairs, and it has the keys from sensor 1, sensor 2, all the way to sensor 6, and the value saves all the data from our sensors, and they are shown here.
As for the MQTT part, first I create things named xdot under the all devices tab, and also I create the rules named xdot under the message routing to select all the data from my topic. This is the circle statement. And the second, I create a lambda function named the final to process the data from the stream, and also to write the data into the DynaDB. And the third, I create a delivery stream. I create a delivery stream to get the data from the source direct put, and transform the data by the function final, and then send it to the Amazon S3. And as a result, we can see from the MQTT test client, if we subscribe to the topic named my topic, and we will receive the data from the Node-RED. This is all the demo data.
Hi, this is Dong Hao. Now I will elaborate on the hardware side. The X dot in the middle serves as the pivot for all other parts, since the hardware will be installed firmly on the solar panel and the battery. The X dot can be powered by the solar power plant system. The altitude data from the solar panel will be collected from inertial measurement unit and analyzed by the X dot to determine if the solar panel is being moved. Location data will be provided by GPS module to track the current location of the solar panel. The formatted data will be continuously uploaded to the gateway to relay to the cloud. The uplink data include a Boolean value that indicates if the solar panel is being moved. two float values, which are latitude and longitude, to illustrate the location of the solar panel. If the solar panel is being moved, the X dot will control the speaker to alert the thief that his behavior is being monitored. For our progress on hardware, we have bought the hardware and connected them together, as you can see here. The solar power bank and the speaker have been tested and they work well. The power distributor has been made and the soldering work for all the components has been completed. Future work will be focused on programming, which is to use Xdot to get data from the inertial measurement unit and GPS module. This is our timetable for your reference. This concludes our progress report.